Welcome back, everybody. This is our first session in NEET previous year questions for chapter Moving Charges and Magnetism of class 12th. Before this video, we have made several videos for others chapter, and all of those videos are available on our YouTube channel's playlist section. You can also find our previous year JEE videos in the JEE playlist. So if some of your friends are preparing for JEE, then you can guide them through those videos. And again, if you like these videos, then do press the like button, share them as much as possible, and subscribe to our channel. And if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, let's start today's video. The first question, that a wire carrying a current I along the positive x-axis has a length L. It is kept in magnetic field. The magnitude of the magnetic force acting on the wire is. So here our length is in positive x-axis. One thing that you have to remember, that force, this is a current carrying conductor, and on a we can say 1D, one dimensional current carrying conductor, which is not a closed. The thing is that conductor should not be in a closed loop. If it is in closed loop, then we have to use the different method. But if it is not in closed loop, then we can say magnetic force will be I into length cross B. And now direction of this length is taken according to the length direction of the current. As here current is in positive x direction, then we will take length in the positive x direction. So length is L. So magnetic force will be, assuming current I, length is L with I vector, cross magnetic field will be there. So it is 2I 3J minus 4K. So it will be I and L comes outside. I cross I will be 0. I cross J is K. So it will be 3K with negative sign. I cross K. Now we know that K cross I is J, and I cross K will be negative J. So negative negative will become positive, and we will have 4J. Now this is the vector form of the force. If we find the magnitude, magnitude will be IL into 3 square plus 4 square. So that will be 5IL. Option A will be the right answer here. Moving to the next one. A infinitely long straight conductor carries a current 5 ampere as shown. An electron is moving with the speed of 10 raised to power 5 meter per second parallel to the conductor. The perpendicular distance between the electron and the current is 20 centimeter. Calculate the magnitude of the force experienced by the electron. So here we have to find magnitude of the force, and that can be find out because we know for a electron is a charged particle. For charged particle, we know magnetic force is Q V cross P. This is the amount of force acting on a moving charge particle. We know the charge, we know the velocity, and we also know the magnetic field. Now let's first find out the magnetic field due to this PQ conductor, as this is a long straight conductor. So magnetic field due to this conductor at 20 centimeter distance will be given by mu naught by 2 pi into I by d. So that will be 4 pi into 10 raised to power minus 7 by twice of pi current is 5 and distance is 20 centimeters, so 20 into 10 raised to power minus 2. So this will be 2. Here we have 10. So this will be 10 raised to power minus 1. It will go on the upper side. It will become 10 raised to power plus 1. So effectively this will be 5 into 10 raised to power minus 6 Tesla. This will be the value of magnetic field. Now, if we see the direction, because here we have cross product, using right hand screw rule, we can find out if we align our thumb along the direction of the current in the loop, in the conductor PQ, then on the upper side, our magnetic field will be coming out of the plane, and in the lower side, magnetic field will be going into the plane. It will be something like this. So, direction of magnetic field out of paper is actually positive K or positive Z direction. So now writing the force, magnetic force will be charge on electron is 1.6 10 raised to power minus 19. Its velocity is mentioned already, 10 raised to power 5 meter per second, and with velocity assuming in x direction. So I cross 5 into 10 raised to power minus 6 K. Now I cross K is J, means the force on electron will be positive upward direction, in the positive upward direction. And finding the magnitude, 1.6 into 5 will be 8 into, we have 10 raised to power minus 19 minus 6 minus 25 plus 5, so 20 minus 20 Newton. That will be the force, means option D will be the right answer. And we can also get the idea regarding direction of the force from the current, because as electron is moving from left to right, means electronic current is in reverse direction. Electronic current will be in the opposite direction of the motion of the electron. And we know when two conductors having opposite direction of current, then they repel each other, and that's what we are experiencing here, that electron is getting repelled or getting away from this conductor. Moving to the next one, a metallic rod of mass per unit length. So we can, mass per unit length is given, means small m by L is 0.5 kg per meter, lying horizontally on a smooth inclined plane which makes angle 30° with the horizontal. The rod is not allowed to slide down by flowing a current through it when a magnetic field of induction 0.25 Tesla acting in the vertical direction. The current flowing in the rod to keep it stationary is. So let's first draw our coordinates. Suppose these are our coordinates and we have a rod at 30° angle. Suppose this is our rod making angle 30°. Now we are it is slide down flowing current through. Okay, it is on a smooth plane, so there is a plane also. The plane is also there. So suppose this is our plane on which this rod is placed. So here yellow line represents our plane and there is a rod on top of it. And here nothing is given regarding friction, so we assume that there is no friction acting on the rod. So let's resolve components for the rod. For rod we have mg downward and there will be components. Those will we can separate, that this will be mg cos theta and this will be mg sin theta. So this is theta, mg, mg cos theta and mg sin theta. Now, as mentioned, that magnetic field is in positive y direction. So we have magnetic field here. And we can have current in this conductor either in the upward direction. Suppose this is O and this is P and this is Q. So we can have direction of the current in the in O to P or direction of current from P to O, depending upon on which direction that current balances the weight. Now we will also have normal reaction, that I forgot to plan here. We will also have normal reaction here. So if we want to rod to not good rod to not to slip, if you want that rod should not slip, then this mg sin theta, that downward force, should be balanced by the magnetic force. And we know for a current carrying conductor, magnetic force is given by I L cross B. So here magnetic force is always perpendicular to the magnetic field. Magnetic force is always perpendicular to the magnetic field, and as here we can say that magnetic field is already in the y direction, means magnetic force can either be in the positive x direction or in the negative x direction. Now let me draw these components in the individual or separately. Suppose this point is R. So at point R we have downward mg, we have mg cos theta. This is our point R. We have a normal reaction here and we have mg sin theta here. Now suppose if magnetic force act in the negative x direction, then it will not be able to balance mg sin theta, then it will support sliding of the rod. So means this magnetic force should act in the positive x direction. If magnetic force is acting like this, then what will happen? We know this angle is already theta. So this angle will be, if this is theta, this will be 90 minus theta. And if we now resolve BIL's component, then what we will get? We will get a component like this, and this angle will be theta. So this component will be BIL cos theta, and we have additional downward component that will be BIL sin theta. So now to balance this equation, we have to write that normal reaction will balance mg cos theta plus BIL sin theta, and mg sin theta will be balanced by BIL cos theta. We know the value of sin theta and cos theta because angle is 30 degree, already known to us. So from this we can find out that mg tangent theta divided by B and L is equal to I. This is the value of the current. Now as we don't have the length, of rod here, but we can write it like m by L, that is mass per unit length, into G into tangent theta divided by magnetic field. Mass per unit length is 0.5 or 5 by 10 into gravity, that is 10, tangent 30, that is 1 by root 3, and magnetic field, that is 0.25 or 25 by 100 or means 4. So this whole uh, expression will reduce to 20 by 5 into 4, 20 by 1.73. So answer will be less than 20, and but will be more than 10, because if this will be denominator would have been 2, then 20 by 2 would be have been 10. So it will be either 14.76 or 11.32, and after solving it comes out to be 11.56. That nearly resembles our option D, because we have approximated gravity here to 10, which actual value is 9.8. So option D will be the right answer. Now moving to the next one. When a proton is released from the rest in a room, it starts with initial acceleration a naught towards the west. When it is projected towards north with speed v naught, it moves with initial acceleration 3 a naught towards the west. The electric and magnetic field in the room are. So we have to find electric and magnetic field. So for that, let's first draw the directions. So suppose these are our directions. This is north, south, east, and west. So it is mentioned that with initial acceleration a node, if we release it rest from the room, in the room, if we release it at rest, now we know that when charge particle is at rest, then at rest magnetic force is zero. There is no magnetic force acting on the charge particle. So in case of it is at rest, only electric force can act on it. And if electric force is acting on it and producing a node acceleration towards the west, means our our electric fields positive should be here and negative should be here, so that electron is accelerated towards the west. As this is an electron, it will be accelerated in this direction. So we can say from the acceleration a node, so the force on electron is given by q node times E, charge times the electric field, and force is also mass time acceleration, so m a node q E. So from that we can say electric field is m a node by q. So that's the value of electric field, and direction of the electric field will be positive to negative or towards the east. So MA node by E towards the east. So here we have option C and option D, which these two are the possible answers for this using the first part, using the only the electric field part. Now when it is projected towards the north, going to the second condition, that if it is projected towards the north, now means electron is going like this. So let's rub this one. Now it is mentioned that electron is going towards the north direction with speed v naught. Then what happens, it moves with an initial acceleration 3 a node towards the west. So it starts moving west. Means if it is start moving west, there is a force acting on it in the west direction, and that force should be perpendicular. So we have to also find the electric and magnetic field in this. So we have to find the value of magnetic field now. So if we see the directions here, we have velocity, we can say, and we are assuming our, you can say, east as x direction, because these two both are in the plane of the, and north as y direction. Means, let me draw so that you can get an idea. Suppose this is our room. Then here what we have, these are our sides. So this is our east direction, this is our west direction, this is our south direction, and this is our north direction. And here these two are in this plane. This direction, these directions arrow are our in plane, or I can say A, B, C, D plane. These directions are arrows are in ABCD plane. If I zoom them slightly, and our up to down direction here, that we will consider using Z direction. So that we can represent like this, that our top to bottom direction will be represented like this. So that will be our Z direction. That will be, we can say, Z or K direction. East we are representing here by X, and north we are representing here by Y direction. So now coming to the our question, that our velocity is in Y direction or is in north. So velocity is in Y direction, or we can say G. Now coming to the force is towards the west. Towards the west means in the negative side. So force is in minus I, and we have to find out magnetic field, that what will be the direction of magnetic field. So we know that magnetic field or force, magnetic force is Q V cross P. Now we are only taking consideration of directions over here only. So force is in negative I, leaving the charge because charge does not have any direction. Velocity is in J. So what should be the value of magnetic field? If we put here K, then J cross K will be I. But we have negative I here, so we have to put here minus K. Means magnetic field is in the Z direction but in the downward. So magnetic field is pointing downwards. And from the option C and D which we had, we can see that in the C we have magnetic field pointing upward, and the D magnetic field pointing downward. So option D will be the right answer here. Now moving to the magnitude part, we will also calculate the magnitude so that all doubts should be clear. Now it is mentioned in the statement that when it moves in the north direction, it has a initial acceleration of 3a node. So initial acceleration is 3a node. Now we know out of this 3a node acceleration, this acceleration is provided by both field. We have here acceleration due to electric field and acceleration due to magnetic field also. So if we consider that electric field, as already mentioned, that electric field is also acting, means a part that is a node is out of this 3a node, a node is due to electric field and remaining 2a node is due to magnetic field, because both of the forces, electric force is also towards the west and magnetic force is also towards the west. So 2a node is due to magnetic field. So force due to magnetic field will be 2a a node into mass and equating it to with, you can say, formula for magnetic force, that will be Q, that is E, and V cross B, that will be VB. So it will be 2m A node divided by EV, that is the value of magnetic field here, and here it is mentioned as 2. So I think there is problem in the option. It should be I, it should be 2. Magnetic field value should be twice of MA node by EV. So with this, let's move to the next question. A long straight wire carries a certain current and produces magnetic field that is given at a perpendicular distance of 5 centimeter from the wire. Electrons situated 5 centimeter from the wires move with velocity 10 raised to power 7 meter per second towards the wire along perpendicular to it. The force experienced by the electron will be. So we have to find out force experienced by the electron at that point. So magnetic field is given to us. So let's first draw the diagram for this question. Suppose this is our wire in the horizontal plane and it has a current that is in positive x direction. So using right hand screw rule, we can find out that magnetic field will be out of the plane on the top of wire and into the plane below the wire. So, and it will take as like circular loop, circular form. So now at this point, this is 5 centimeter. We have an electron and that is coming towards the wire with perpendicular, and electron is moving downward. At this point its velocity is 10 raised to power 7 meter per second. So velocity of electron is in negative y direction and magnetic field out of the plane in the positive k direction. So now if we write formula for the magnetic force will be Q V cross B. Charge is 1.6 into 10 raised to power minus 19. Velocity is 10 raised to power 7 in minus j direction or negative y direction. Cross product with the magnetic field that is already given to us, 2 into 10 raised to power minus 4 in the positive k direction, assuming this value direction of current. So solving these we will get 3.2 into 10 raised to power minus 12 and minus 16 with minus j cross k. So j cross k is I and here we have minus I sign. Means magnetic force will be acting in the negative x direction according to this direction of the current. So that is 3.2 into 10 raised to power minus 16. So option B will be the right answer here. Moving to the next one. A uniform electric field and a uniform magnetic field are acting along the same direction in a certain region. If electron projected in region such that velocity is pointing along the direction of the field, the electron. So we have a uniform electric and uniform magnetic field, both are in the same direction. So this is our electric and this is our magnetic field. Both are in same direction, suppose positive I. And also mentioned that electron projected with velocity along the same direction. So electron is also projected with velocity in the same direction. So we know the direction of electric field. If this is electric field, then it is from positive to negative. And electron is projected with velocity along the direction of the electric field, so electron will feel a repulsive force. So electric force will be repulsive, that will decrease its velocity, or there will be retardation due to electric field. Now coming to the magnetic field, as magnetic field and velocity both are in same direction, and we know that Fm is QV cross P. So their cross product will be zero, and there will be no magnetic force. So only electric force will be acting here, and even that will be in the opposite direction. So the, we can say, velocity of the electron will decrease. But as mentioned in the question, we don't, here in the question it is not mentioned that what is the actual direction, or what is the initial direction. So we know it will change its direction. If it was if it was initially moving in the left, then it will turn into right, and if it was initially moving in the right, then it will turn into left. Direction will be changed, but initially we don't have any direction, so we will only say that speed will decrease with time. So option A will be the right answer here. So with this we end this video here. Hopefully what we have covered is helpful to you. Again, if you have any doubts or suggestion, then you can put them in comment section. I will try to implement or solve. And if you like this video, then do press like button, share it as much as possible, and subscribe to our channel. Also, if you like to donate us some amount or help us financially, then you can scan any of these QR codes in front of your screen and donate any amount. So with this, again, thanks for watching, and we will meet in next video.